The coupled field analysis considers interactions between air and structure with a transient strong FSI coupling. The workflow is also adapted for a general study of a structure in a heavier fluid like water. Reducing the model size with the symmetry for watch case and air while keeping a complete gong is possible. Geometry and mesh were already prepared. The end time is set just long enough so that you can hear both impulse and resonance. Time stepping controls are required for this transient vibroacoustic analysis to sample at a high enough rate. The analysis is kept linear here, but could be nonlinear as well. Define the degrees of freedom for this multiphysics analysis. Some of the bodies will have acoustic pressure, and others only structural deformations. An absorbing boundary condition prevents wave reflections. All faces between structure and air are identified automatically for strong fluid-structure interaction. The hammer force is included as a time signal. This data could also be imported from measurements or another simulation. Note that the hammer could also be added in this model, and its impact simulated by switching on non-linearities. Further structural boundary conditions are added. Remember that we model half the case and a full gong to save time. Here's a little trick for selecting the exact surfaces and data we want to keep in the results file in order to save disk space. Here, we only keep the gong and cut faces. In this example, we focus on the near-field acoustic pressure. A far-field microphone, located further outside of the mesh region, would also be possible. Displaying results while the simulation is running is a convenient way to check that everything runs as planned. We want to see how the wave propagates along the gong over the first time steps. Now that the simulation is finished, we can review the stored fields. The most amazing part is the possibility to export an audio wave file that can either be played or imported into Ansys Sound for further analysis. A fast Fourier transform provides a waterfall diagram that allows you to visualize impulse and resonance and dive deeper into a psychoacoustic analysis with specific metrics, but that's another story.